So, hello everyone and welcome back to another video, and this one is an exciting one. So, this is the GTX 580 Phantom power board, and it has changed since the last time you've seen it. This has been a lot of work and pain because me being me, I never get what I want. I always have to deal with some other trash. And yeah, I had to deal with a lot of issues on this one, but it does work. Kinda. Now, it's still a bit weird in some ways, but it does give you an output now on both VRMs. Both vCore and vMem do work now. So yeah, let me tell you how I got here. So I in the last video you saw me cut the card in half, sand it down, and then maybe talk about what I'm going to do. Yeah, and I tried to do that, but then I discovered some things about this card, that being that my previous plan wasn't necessary and that I had to instead do something else to make it work. That was totally unexpected. I still don't know why, but my fix worked, but I've never seen any mention anywhere that you might have to do this. So, basically, when you're doing a DIY e-power board, what you have to do is you have to create two power sources on the board. One 3.3 volt, the other one 5 volt, because usually a graphics card uses 12 volts, 3.3 and 5 volts power for their main, as their power inputs. And these PCI Express connectors over here only give you 12 volts. The 3.3 volts comes from the PCI Express slot, which we cut off, and the 5 volts is usually coming from a 5 volt low dropout regulator that was on the part of the card that we cut off. So we have to replace both of those power sources. Technically, it turns out we don't have to on this card. So usually your PWM controller, which I was mostly following a guide for the GTX 480 reference, which is using a different board than this and also a different controller and MOSFETs and all that stuff. So I could only assume that I would have to do the same things, which usually is a good idea, but this specific controller is very, very different from from everything else I've seen to date. So usually you need to have these power sources for your PWM controller, and on the surface it looks like you need it here too. You have three capacitors on the card, on the PWM controller. This one right here, this one is 3.3 volts, you have one right here, this is 12 volts, and then you have one here that is 5 volts. So you would think that you would have to replace the power for these two capacitors if you cut the card. You don't, actually. If you look at the datasheet, which I should have done more closely, the datasheet states that the 3.3 volts is coming from the controller, not from an external power source, because the controller has a low dropout regulator for 3.3 volts integrated into it. And the 5 volts is actually 12 volts that's just being divided down by a voltage divider using these two resistors over here. These are 680 ohms in parallel, so you get 340 ohms, which is what the datasheet says. And then 12 volts becomes 5 volts because these resistors together with the controller form a voltage divider. So you get, it's not exact 5 volts, it's like 5.17 volts, but you do get the two power rails that I assumed would be missing. And I guess on pretty much every card these would be missing, but for some reason the ADP 4100 on here does not need these inputs. So these two regulators that I put on here are actually completely redundant. So you can actually see the right one is not hooked up to anything. The left one is though. So the blue wire, you still have to do one thing. You have to pull the enable pin of the controller high, because otherwise the VRM won't start. Because normally the enable signal comes from the GPU, and well, no more GPU there. So you have to get the enable signal from something else. So yeah, I'm using one of these regulator, which I would have used the 3.3 volt anyway for this. I'm using one of these regulators to just solder to a pad that is connected to the enable pin. And this is putting out 1.3 volts actually, not 3.3 volts. I've set this one to 1.3 because I've measured, before cutting the card, I've measured pretty much any thing that's not just a resistor around the controller, and the enable pad read 1.3 volts, so I've just set this to 1.3 volts also. Because, well, I don't need to power anything else with it, so I can just set it to precisely the voltage it had before. And then theoretically, it should power up, and it did. Only problem was, so if I hook up a multimeter and I power this thing on, it would show nearly 1 volt for a second, and then start ramping down, like not linearly, like in this way, until it reaches about 100 millivolts, and then it just sits there. And pretty much like the power good signal goes missing, the controller is signaling the drivers that the VRM should shut down, and like, yeah, things are being pulled down because the output voltage is not what it should be. And I took the entire evening yesterday and the entire morning today to try to fix this issue. Because it can't be just like, oh, there's some power rail missing, or like, oh, the drivers are not getting power. Everything is getting power because the VRM does work for that 1 second, and then it just lowers the voltage to unusable levels. So, yeah, I really had no idea what to do. And then today, like this morning, I just had the idea. The voltage is okay, and then it goes low. So the VRM is working, but something is telling the VRM to go down with the voltage. And pretty much the only thing that I could think of that tells the voltage to go down and not the VRM to shut off, it would still sit at around 100 millivolts, so it is running, but it's just putting out a way too low voltage. And I was thinking of things that could cause this, and the only thing that I could think of is load line calibration, so LOC. And I was thinking, okay, maybe cutting the card caused something within the current sense system that made the LLC just react overly aggressively to the voltage and just reduce the voltage way too much, because maybe it's thinking it's pulling like 1,000 amps or something. So yeah, what I did is this red wire, and this red wire is the reason why it's working now. So in the data sheet, it says, so there's a pin on the left side that's LL set or something, like it sets the load line. There, you put a resistor from this over to another pin down there to set the load line. What I've done is I've connected this pin with just a wire to this pin, and the datasheet actually states you're supposed to do this if you just want to disable the load line. So what I've done is disable the load line. So there's just the resistance of the wire, which is basically should be 0. I have a suspicion it's not, but it should be 0. And this now should disable the load line completely. And I was so happy when I fired this thing up and I got 825 millivolts on output. That's not a volt, it's less than it blipped for a second before, but this is about the voltage that a Fermi card could run on in idle. Because, well, there's nothing connected to this, there's basically no current going through this. So, yeah, it would make sense that the card is spitting out idle voltage. And 825 millivolts it's kind of low for Fermi, but it is what Fermi would be able to run on in idle. Like, I've never actually measured the idle voltage on Fermi, but I know it's below a volt. So, yeah. And with this red wire, this now works. And the funny thing is, VMEM also started working. Before it was at 0 volts, because I thought, well, probably I have to pull the enable pin of this one also high, and I don't have a datasheet for this controller because it's not like it just says DQ equals DC. That's a product code you have to decode, and well, I would need to know from what manufacturer it is before, because it's not Richtech. I do have the decoding PDF for Richtech, and that leads me, they have something that is DQ equals, but it's not a PWM controller, it's something else. So this is I guess it's on semiconductor, because like this is on semiconductor and the drivers are. It could be something entirely different. So I was just thinking, yeah, it's not working because I also need to pull the enable pin high. Turns out I don't. Turns out that this is just always running unless it's getting pulled low by this, which it did, because the voltage was all wonky. But now where the voltage is actually something you could use, this is no longer pulling everything else low. This is running, and you actually get 1.6 volts on VMEM output, which is GDDR5 voltage. So both VRMs are working now. The only thing I have to do now, actually there's two things I have to do now. More like, well, you could split up the last thing into two more, so maybe three things. I do have to add a volt mod to vCore, which I had a volt mod attached to this 2 times already, but it didn't work. Like maybe I was just soldering to the wrong IC. Like it's really complicated with the layout down there. And there is one resistor that's connected to the feedback. It's really hard to see. It's right under the red cable. There's one resistor that's somehow it must have come loose, and it's not on its pad anymore. It's still contacting the pad, but it's like shifted to the side by a lot. And I really am comfortable with soldering in that area, but I do have to solder there because that's where the feedback pin goes to. So like it's working, the resistor is still doing what it should, but it's like really off to the side, and I'm not comfortable with it being like that. So I just don't want to touch that area. So I had, like the first time I had the feedback mod connected, I still didn't have this running, so it did nothing. The second time, for some reason, this halved the voltage. So I think I might have just soldered to the wrong thing and accidentally decreased the voltage instead of increasing it. So that's why there's no volt mod right now. At some point, like I think I'm gonna try to hook this up to something first and look if it actually can power something, and then worry about what voltage it spits out. But right now it's spitting out a voltage that does allow things to work. So yeah, but I do need a volt mod on this because I won't be able to, well, control the voltage otherwise, and it would be a pretty bad e-power board if that was the case. And then the second thing is I need to give the VRM a better 12 volt source, because as it is right now, I'm not taking the heatsink off of this because the thermal pads are in really bad condition and basically are disintegrating every time I take this off, and I don't have any more thermal pads to replace them, so I'm taking this on, letting this sit here. But what's basically happening is the PCB is divided up. It has 3 separate 12 volts power planes, which, well, you have 3 separate 12 volt sources normally, just I've cut one of them off. So what's the case is the first 4 vCore phases are on the 8 pin, the other 2 are on the 6 pin, and VMEM is on the PCI Express slot, which is no longer there. It does work because I've connected these 2 wires, like this is vCore, this is VMEM, like these capacitors are input capacitors for vCore, VMEM. And as you can see, I've soldered the converters to VMEM and then figured out, oh, it's PCI Express slot, I need to get 12 volts to this. So I took these wires, connected it to vCore where there is 12 volts to power these 2 converters. That's okay, like there's basically no current going through there, but there is some substantial amount of current going through to VMEM if I want to power anything with it. And currently these 4 memory chips are still being powered by VMEM. So yeah, and the thing is, literally all of the current for VMEM is going through these 2 AWG28 wires. And yeah, I'm gonna melt them if I try to power anything substantial. Like if these memory chips idling are probably okay, but if these would be under load, I think these wires would already be overloaded. So I need to give VMEM a better 12 volt source. Only problem is like you can probably see by the quality of the solder right here, where I shorted out the PS2 sense pins. I absolutely hate soldering to these big connections, or like anything through hole, like capacitors, inductors. I hate soldering to these. because I never get it working, and you can see like it looks really bad, and it was a pain. So that's why I've been procrastinating on giving VMem a proper 12 volt source. And I also don't really think I'm gonna do it anytime soon, because having VMem work on this was just a secondary objective, and I thought I would have to like set it aside and work on getting that to work also, but it just works now, I guess, which I'm happy about. But yeah, I wasn't really planning on using it, and I'm still not planning on using it now. But it's just like having, if I have like a super, if I ever want to just completely e-power everything on a card except maybe the PAX rail, I can use this power board for it, and I don't like, I have 2 output voltages, not just one, and that's just a nice thing to have. But yeah, this needs a proper 12 volt source, and that will be painful. It will not be fun getting a proper 12 volt source to VMem. And then also, well, I still have 4 memory chips on here from when I cut the card. These are still connected to VMem. These are still consuming power from VMem. You could technically just use VMem with these still connected, but it would be really inefficient, because you would always have 4 memory chips just consuming away your power. And yeah, so I have to remove these in a way that I don't damage anything else. But yeah, as I've said right now, well, these are technically consuming power because VMem is powered up and these are connected to VMem, but these are idling. This is gonna be like 2 watts or something. And at the moment, I don't care. So the number 1 priority is getting voltage control on vCore. But I think before I do that, I'm gonna test it on something. I'm gonna have to figure out what. Something that I have to power and that consumes enough, like that pulls enough current to get this to go out of load. Like I still don't know the state of the current sense circuitry. It might have been just the load line circuitry that screwed me over here. It might have been that the entire current sense is messed up and reading way too high current values. That might be an issue. Like, I don't think it is, because it is giving me these 800 millivolts, which actually now it doesn't. This red wire disconnected at some point and I resoldered it, and now I'm getting like 780 millivolts instead of 825. It's slightly lower, which is, I think this wire, the connection, is not good enough, and there's still some resistance, and there's still technically some amount of load line that's overreacting on this. So I might have to get a better connection from this wire. But 780 millivolts is still good enough. Like the GTX 590 ran on 0.7 volts. So still less than this. And, well, the 590 used the same GPU that this card had before I cut it. So yeah, I just have to find something that pulls enough current for this to maybe get out of idle voltage. Thing is just, if I if I connect it to something like this, the GTX 970, the MSI one, which this is my plan. My end goal is to connect this e-power to this card and then have it like, kind of weirdly hanging off like this or something. Which I wouldn't have to use VMem for this, because VMem on this card is still perfectly fine and working. It just needs a vCore VRAM, because something made the VRAM shut down. I don't know. I just removed all of the VRAM because I was troubleshooting this card for so long and I just gave up. And I thought like, well, it can't disable vCore if there's no vCore. So yeah, the end goal is to e-power this card with this. But you might remember that I made a video where I was, like, the first e-power centric video I ever made was not about the 970, it was, get it from the shelf, it was about this card, my GTX 460 SE, which has been upgraded with a new VRAM. But yeah, I was thinking of testing this card first with the e-power. Upgrading the VRAM on this was just like a test. I was practicing for replacing the VRAM on the RX 270, which I'm actually in the process of doing right now. Thing is just, for some reason, the card now has a short circuit from vCore to ground. I don't know why. It was working, it was just not working as expected. But now it has a short circuit from vCore to ground, which is like, it wouldn't fire up with that. I don't know what's up with it. Maybe I was measuring things wrong. It's just I put it aside right now because I don't want to deal with a short circuit on another card. So yeah. But the original plan was to test the ePower on this card, which I think I'm still gonna do, I guess. Actually, I'm not sure about it anymore. Like, because the upgrade VRAM actually works pretty fine. And now I think of it, connecting this thing to the 460 just to test it would be a lot of work for relatively little gain, because this VRAM is working perfectly fine. Because this is not the reference VRAM anymore. This has upgraded low sides that are like, these are 60 amps for, well, they drop off if you heat them up a lot. But these can do 60 amps, and you have two of these, so you can technically do 120 amps for all of the three phases, which I'm bad at doing math in my head. But 3 times 120 amps is what this can pull now. It was barely doing 150 before with the entire VRM, so this is not a 3 times performance increase, but it's well above a 2 times. So yeah, I'm actually liking the card right now. Like, I should just vote mod this and try to get some nice benchmarks for HW board, because I'm still second in place for this card, because only ever 3 people benchmark this thing in Firestrike, and I'm second place right now. So yeah, back on the shelf. So yeah, so coming back to this, it does work now. It is my, well, yeah, I would say it is my most difficult thing yet that I've done. Just because just dealing with it and fixing that LLC thing, which I'm still kind of worried it's not entirely fixed, because, well, it gave me, like, now it's giving me 780 millivolts. I just hope that when I put something to this and pull some current, that the problem will solve itself. But I could just also put a volt mod on this that's very aggressive and, like, take those 780 millivolts and turn them into 1 volt for standard. And I have to do a volt mod on this anyways, so might just do that. But yeah, I'm really happy that this works out, that this works now. Actually, the nice thing is it really looks great. Like, this side looks really great because of the giant heatsink. And then this side looks really great because, well, these 2 wires are not really that great managed, but there's not anything hanging off of the card. And the nice thing is, these 2 have LEDs when they're running, so it even has technically RGB now, because this one has a red one, this one has a blue LED, because these are slightly, like, I think whoever makes these just chucks a random LED on these, and I just happened to end up with one that has a red and a blue LED. So, well, it has RB. The G is still missing. It has like 3/4 of RGB now. Yeah, it looks pretty nice. I think, like, this is nicely done, and like these are plasti dipped on, not like double-sided taped or anything. Like, this is, well, you can see I cut some plasti dip off here, and there's actually a screw down there where I just put the screwdriver through the plasti dip. But yeah, I think this is looking very, very clean for the first ePower board that I made. It's not the first that I attempted, but it's the first that I made. Like, I think I can show my failure before this. This is what I had before. This is what remains of the GTX 470 that died. And I tried to do this first because, well, the card was dead anyway. And I just thought, this can't be so difficult. I ended up it ended up not working, also because of a weird issue. Not the same that this had, it just never worked. Like, it never gave me an output. And then while trying to mess with it, I don't know if you can see it, I ripped out the feedback trace. So this is done. This is like done. It's technically possible to redo the traces on this, but not by me, but with my current skill set and even equipment. A skilled repair technician might be able to repair that trace, but like, this is the 4-phase from an NVIDIA reference card. To be fair, a card that consumes a lot of power, but it's still a 4-phase. I don't have a heatsink for this. The VMEM VRM on this actually has a short circuit from VMEM to ground. This is not working. And I'm just... I mean, even if I fix the trace, this never gave me an output to begin with. So, yeah. This is pretty much a failure. I think I'm gonna steal these capacitors off it though, and then just put it up on the wall of shame, together with the other side of this and what remains of the 580. So yeah, like the wall of shame is not exclusively for hardware that dies. It mostly is for that, but it's also for showing people my shame for doing stupid things like that for 70. But this works. This is a working e-power board. And yeah, I just have to use it now and properly finish it with the volt mod. But though like, if you just have a broken card and want to have it running again, this would be enough for that. It is not enough for like extreme overclocking because, well, the voltage won't go high. But yeah, I do intend to use this for extreme overclocking of that 970 because, well, yeah, it's a 970. It's the one that doesn't, like, one of the 970s works in the way that it displays an image, but it doesn't run benchmarks. It shuts off, likely because it only has 3 phases of 4 left, and these phases were not that strong to begin with. So yeah, that 970 can be fully repaired by just putting on the fourth phase that I removed because that one was dead. The other 970, just as I've said, it has a random something. I spent so many hours trying to figure out why that VRAM wasn't working. In the end, I just said, screw it, I'm e-powering it. This is what I'm e-powering it with. And then hopefully, I have no idea how good the core of the memory is. It never ran, but, well, this has a stupid heatsink. It has a stupidly massive heatsink. And the VRM, the layout to begin with, is pretty nice for thermals. And though this is just a 6-phase, and the 970 also had a 6-phase, this 6-phase should be a lot more powerful. Like, this was powering a GTX 580, and yeah, I'm not sure if I've said that in the last video. I think I have. Like, from the LTT Discord, Madness has a card with this PCB, just that it's a 570 instead of a 580, so these 2 memory modules are missing and the core is slightly different. But the VRM is the same. And he was able to pull like 410, 430 watts through that VRM. I kind of doubt that the 970 will pull that much power on anything like ambient cooling, because I'm gonna water cool it. I might do sub-ambient, but like 410, even if I go with the lower number, like 410 watts, that's like what a massively overclocked RTX 3080 would do. You can't do it on a 2080, not without a power mod. You can't do it on a 1080 Ti, not without a power mod. You might be able to do it on 980 Ti's and 780 Ti's, just because these are 28 nanometer, but like, I'm talking about a 970, not a 980 Ti. So, I think this is powerful enough. Yeah, and we are at 30 minutes now. Well, it's one of the videos that are really important to me, like more important to me, because I finally managed to, like, we're nearing the end game here. Like, I started doing these videos about a year ago. I started extreme, like, modding for extreme overclocking half a year ago, less than half a year ago, I think. And now I've made a power board that works. Like, I've never done liquid nitrogen or dry ice overclocking, but it's definitely on the list. And we're getting pretty close to that with, now I have the tools to prep a card with a proper VRM to do it. And like, yeah, I could just use an extreme overclocking card and not modify it at all and to take it on sub-ambient, but like, doing it with this is just so much more badass. So, yeah. And also, like, I just really want to e-power a card, and getting that thing on liquid nitrogen or any kind of sub-ambient cooling. It's just a very nice personal achievement. So yeah. But I think I've rambled on for this long enough. So yeah. GTX 580 Phantom e-power. It is working. You do get voltage on both VRMs. And the next time you see this, it will either be finished with the volt mod, or I will have attached it to something to test it with. And it will hopefully be running. That would be kind of weird if I now say it's running and then the next video, oh, it broke, or like it wasn't working. But yeah, like you get output on this. And yeah. Also, the next thing, another thing I can grab from the shelf. I was really thinking of putting this card out of its misery. Like, this is the GTX 480 that, this is a reference 480. I got this in extremely poor condition. Like, caps missing all over the place. It's just generally dirty. There's like a lot of these screws are missing. The heatsink was in really bad condition, so I put on this one. Yeah, like I've modded this in a video where I sort of live modded it, though there was a lot of fast forwarding. So both rails are volt modded on this. Because VMem is volt modded. Like, these read points are like pretty meh. There's one capacitor back here to replace some of the caps that are missing from the core. And the thing is just, it works. It works. But I just kind of don't know what to do with it. The memory is... I actually don't know how for 400 series. Like, for 500 series standards, the memory is pretty bad. For 400 series standards, I think it's still pretty bad. Because the 460, at least the 460, both of these are Samsung, and the 460 is significantly outperforming this. Like, the 460 does 2100 and I think 2200 with a mod. This does like 1900 or something. So yeah, and the core on this is also, it's like a 915 megahertz or something. It's for this class of heatsink on it. Which, to be fair, yeah, it's not delidded, but the thermals are fine. The thermals are like 63 degrees under full load. This card just doesn't overclock well. And I don't have other 480s. This is my only 480. I do have a whole bunch of 580s with, well, -1 now, but like I still have 4. Like, is it 4? Yeah, 4 580s. So I can do quad SLI if I want. I don't need one of these. Well, like 480s and 580s. Like, the 580 has more cores, and that's like the only difference. And I was thinking of like, I have full documentation. Like, I was doing this trying to figure it out myself. I do have proper complete documentation on how to turn this into an e-power. And I do have this kind of personal commitment to not destroy good cards, but like, and with good cards I mean working cards. I'm kind of considering breaking that with this one, because the VRM is, like, I do have the base plate still for this. It's nowhere near the heatsink from this, But I do have the base plate for it, I do have thermal pads for it. I do have complete documentation how to turn this into an e-power. And the core and the memory that this is attached to are pretty meh. Bad even. So I'm kind of strongly considering making this my second e-power. Because the 970 is not the only thing I want to e-power. There is also the GTX 670. Which the GTX 670 has, it's like a 670 core on a 680 reference PCB with slight layout changes. It's a 4-phase, it's a pretty crappy 4-phase, it's an NVIDIA reference VRM. This is also an NVIDIA reference VRM, but this is a 6-phase on a core that is not a 670. So this as an e-power, which it's already completely modded, this would do fine on the 670, and I'm kind of thinking of, I do like the 670 a lot, even with the crappy VRM. The memory is pretty good. It's my only 28nm Samsung card, so the memory is pretty good. The core is reasonable. So like with the VRM upgrade, I could take this thing a lot higher. Like on the 670, I literally can't change the voltage. It just can't. And with that VRM, I wouldn't. Like with this, I could scale up voltage so much. And I mean, literally, I have no idea what to do with this card. Because the core is just so bad. It's just so bad. And the memory is bad. And like, yeah, I could cap mod it. I don't want to. The PCB is in such a bad condition. I just don't like. If anything, I'm just gonna run this for like a video. How was the GTX 470 in X year or versus X graphics card? That's basically the only use I would get out of this. So I'm strongly considering destroying this card to significantly upgrade another. And now we are at 37 minutes. So yeah, I'm gonna get this out of the video. Yeah, so the video is long enough by now. Everyone who's still watching, thank you. Yeah, so I got this e-power to work. I have a working e-power now. So yeah, that's it for the video. I really can't think of anything more to ramble about. So thank you all for watching of this really long video. Hope you enjoyed, and until see each other next time. Goodbye.